In this lesson, we're going to talk about simplifying radicals. We're going to move on into another section, another portion of algebra that's very important. You're going to use this time and time and time again, and it's going to become very useful to get it right, so that we're going to work a lot of numerous problems here. So what if you have something like the square root of 20? The question is, simplify that. Okay? Obviously, you can put 20 in your calculator and you can hit the square root button. You'll get a number. Okay? But that's not what we're trying to do here. Remember that the square root is, by definition, okay, what you're trying to find there is you're trying to find some number that when you multiply it by itself gives you what's under here. So let's say if you had square root of 25, just for review, that's going to be equal to 5, because what you're trying to do is find 5 times 5 is 25. Okay? What you're trying to do is 5 times 5 is 25. And so that's why the answer is 5. And just to kind of, before we actually get on to my first problem, we'll just kind of continue working with this. The way you do this is to actually, if you didn't know the answer is, you draw what I call a tree here, and you try to write numbers down that multiply together to give you 25. So the only thing I can think of off the top of my head that multiplies together to give me 25 is 5 times 5. And that's just what I know gives me 25. I can't write anything, I could come down here and write 1 times 5 gives me 5, but that really doesn't help me. What I know that I can use here is 5 times 5. Because it's a square root, okay, not a cubed root or a quad root or something like that, because it's a square root, what I look for to find the answer here is pairs of numbers. I'm trying to find numbers that occur twice here under the tree. When I find a number that occurs twice under the tree, I just bring it outside the radical and I write it one time. So it's almost like I'm writing numbers down that multiply together to give me the number up here, and then of everything that I write down here, I just try to find pairs of 2, and then I take the pair and I take that number and I pull it out of the radical. Because that's exactly the definition. I'm trying to find numbers that when they multiply by themselves give me the number underneath the radical. And so in this case it's 5. Okay? So we'll move on to the original problem, which is how do you simplify this? Well, I can draw my tree like this, and I'm just going to write down some numbers that multiply together to give me 20. So off the top of my head, I can think of 2 times 10. 2, I can write 1 times 2, but you don't ever write those down. You don't write things down that are 1 times whatever. So this goes as far as you can. Under 10, I can write 2 times 5. Okay? So then I just draw a dotted line around these two numbers because I found a pair of numbers, and I pull those outside the radical, and I put a 2 there. But notice I've still got this 5 left over, and it's all by itself. So you can't just pull it out, and you can't just ignore it. So what you're left with is still the square root of 5. So the answer to this problem, when you say simplify square root of 20, the answer is 2 times the square root of 5. If you put this in your calculator, you take the square root of 5, you put it in there, and then you multiply by 2, you will get the same number that's on the left. You'll get the same exact thing, and that's exactly why they're equal here. So you look for pairs. And we'll go ahead and work a lot of examples here so you get the hang of things. What if I had the square root of 50? Well, off the top of my head, I know that 2 times 25 will give me 50. Can't do anything more with the 2, but I know that under 25, 5 times 5 will give me 25. Okay? And looky here, I found a pair. So I pull it out of the radical, 5. But this 2 is left all by himself. You can't get rid of him. You can't ignore him. So you just put him right back under. 5 times the square root of 2 is exactly the same number as the square root of 50. What if I have the square root of 48? Okay. I know that 12 times 4 gives me 48. I also know that 3 times 4 gives me 12. And I also know that 2 times 2 gives me 4. And that's as far as I can go down the tree here. Over here, I know that 2 times 2 can give me this 4. And when you're looking for your pairs, in a chart that has this many levels to it, you want to look for your pairs and the lowest, kind of in the lowest area. You want to draw kind of a dotted line in your head here. You want to look for pairs in all of these numbers that you've made there at the very bottom, the bottommost area. Okay. Here I have a pair, which is 2. Here I have another pair, which is 2. So I'm going to use that. Okay, I'm going to say this is equal to this 2. I'm going to pull it out, 2. Now I've got another 2, and I'm going to pull it out. When you pull it out, it just becomes multiplied with the first 2 that I pulled out. And then underneath the radical, I've got my lonely 3, which nothing ever happened to it. 2 times 2 is just 4, and I just keep my 3, my square root of 3, and that's the answer, 4 times the square root of 3. Not bad, right? Not too bad. So, you just think of in your head what can multiply with whatever else, and you go from there. Let's move into something a little bit different. What if I had something like 25 times x, square root of 25 times x? Okay. Well, what I'm trying to do here is, I'm going to do it like this. 25x is just 25 times x, right? That gives me 25x. Under 25, I've got 5 times 5, and that's as far as I can go. Of course, x, that's as far as I can go there, okay? I've got a pair right here, so I'll pull it out of the radical, and I'll put a single 5 down, but I've got to carry my x over here because it's lonely and there's nothing else I can do with it. It's got to stay under the radical. 5 times the square root of x. I show you this problem just to prove to you that there's nothing special about the letter here. It's just another symbol for a number, so you've got to carry it along, just like you would expect. What if you had something a little bit more complicated, like the square root of a squared b? Okay, well this is just simply equal to a squared times b, right? That's the definition. And then a squared is just simply a times a. So, what do I have here? I have a pair here, a and a. Of course, b is just all by himself. So in the end, I pull the a out, and I leave the b in. A times the square root of b. And that's about all I can do with that. Multiply whatever's under there, a squared times b. A squared is a times a, and you just look for pairs. Okay. What if I had the square root of a times x squared y? Okay. Well, that's just a, okay, times x squared times y. I can do 3 of them. That's no problem. Okay. X squared is just x times x. Okay. And so in the end, what I'm going to have is the x comes out because it's a pair. So that's x times the square root of a y. Okay? Now let's do something a little bit more interesting. What if I had 1/5 times x squared times y times the square root of 50 x squared y squared? Okay? Well, this is just something out in front, so I don't need to worry about that right away. But for this, 50 is 2 times 25, and this is, actually just to make it absolutely clear, let me show what I'm doing here. This is just 50 times x squared times y squared. Okay? 50 is 2 times 25. 25 is 5 times 5. Of course, the x squared is just x times x. The y squared is y times y. So in the bottom tier, the bottommost level here where I'm looking for my pairs is this stuff. Okay? And I only find a pair here, and a pair here, and a pair here. So this is equal to, I'm just going to write what I had here at the beginning, 1/5 x squared y times. Now I'm going to deal with the radical. I've got a 5 here times an x times a y, and then I'm left with, under the radical, this 2, which is left over. Okay? 5 times 1/5 is just going to be 1, because that's going to be 5 over 5, so this goes away with this. X times x squared is x to the third, because remember you add the exponents. Y times y is y squared, and then I'm just going to keep my square root of 2, like that. And that's the answer there. So you just work very methodically. You just kind of simplify through it and figure out, exactly which pairs you're going to have and so on. What if you had something like, just to do something a little bit different, square root of 25 over 9. What I'm going to share with you is when you have a fraction inside of a radical, this is called a radical, the square root here, it's the same thing as the square root of 25 over the square root of 9. Okay? And that's just something you're going to have to remember. Anytime you have a fraction under a radical, you can apply the radical to the top separately from the bottom. So, if you just happen to remember, the square root of 25 is 5, because 5 times 5 is 25. The square root of 9 is 3, because 3 times 3 is 9. Well, then there you go. The answer is 5/3. Another example of that is, just so you know, if you have square root of 81 over 64, that's just going to be the square root of 81 over the square root of 64. Square root of 81 is going to be one of those things you're just going to memorize eventually, is 9, because 9 times 9 is 81. 64, square root of that is just 8, because 8 times 8 is 64. And then there you go. Okay. What if you had something like, something a little more complicated? 72x to the third over y squared, all take the square root of that whole thing. Well, what I'm going to have is the square root of 72x to the third on the top and the square root of y squared on the bottom. Okay? I'm going to work with the top here. Okay? 72x to the third. Let's just work with that. That's going to be equal to 72 times x to the third. Okay. For the 72, it's 9 times 8. 8 times 9 is 72. For the 9, it's 3 times 3. For the 8, it's 2 times 4 is 8. But then 4 is just 2 times 2. That's a lot of simplification there. Okay. Under the x, cubed is x times x times x. So I'm looking for pairs here, and I'm going to look everything under here, the lastmost tier. Okay, so to simplify the top here is a 3, because here's a pair. Got another pair here, 2, so that's times 2. I've got another pair here, which is the x. But inside the radical, I've got a lonely 2 and a lonely x. So I've got a lonely 2x here. So this is going to be 3 times 2 is 6x root 2x. But don't forget, that's not the whole problem. That was just what was on the top. So this, 6x square root of 2x divided by y squared. Square root of y squared is just y, because that's the definition. You've got y squared in here. If you were to draw your pyramid, it would be y times y, and then that's just one thing. You pull it out, and that's it. Square root of y squared is y. And just as a side note, as you solve equations, the opposite of a square root is a square. Okay, so when you have a square root of a square, well then you just get back your answer. And that's just something you're going to learn as we go off and we solve some more equations. Okay, let's say, and I think this may be our last example here, let's say you have 125 m squared n squared over 64n, and this is all square rooted like this. Okay. Again, that's just going to be equal to square root 125 m squared n squared over square root 64n. So for the top, I've got 125 m squared n squared. This, okay, is just going to be, for the 125, is going to be 125, okay, times m squared times n squared. 125, if you think about it, can be written as 5 times 5 times 5. 5 times 5 is 25. 25 times 5 gives you 125. This is just m times m, and this is just n times n. So if I look for my pairs, I've got a pair here, got a pair here, got a pair here. So for this one, I'm going to have a 5 I'm going to pull out. I'm going to have an m I'm going to pull out. I'm also going to have an n I'm going to pull out, but inside I've got a lonely 5. Okay? This is not the whole answer, because we also have to deal with this. Okay? 64n is just 64 times n, and then 64 is just 8 times 8. So if you wanted to simplify that, you would have this pair 8 that would come out, and you would have 8 times the square root of n, which is what was left over in the inside. So at the end of the day, the answer is going to be the top, which is 5mn times the square root of 5 divided by 8 times the square root of n. Okay? Now, one thing you're going to notice in your classes is that mathematicians, for whatever reason, don't like to see square roots in the denominator. They just don't like it. So what they ask you to do a lot of times is get rid of the square roots in the denominator. And that can be easily done by multiplying the top and bottom by whatever radical you have in the denominator over here. Okay, so we can get rid of this for right now. Okay, when you do this, you'll have 5 times m times n times the square root 5n over 8 times the square root of n times n is n squared, but then you see the square root of n squared is just n. So you got 5mn square root 5n over 8n. This n cancels with this n, because n divided by n is 1. The final answer is 5m square root 5n over 8.